Okay, so this video is describing what you need to have for your lab write-up for the energy transformations lab. All right, so let's take a look here of what we have. Again, this is your energy transformations thing on Canvas. You just go to this module. You can scroll all the way down to here, and then it brings you to this, the checklist. Okay, so let's kind of go through this. So this is for your write-up. So you've already collected your data and stuff like that. You've watched the other video, and now you're on to writing up your lab. So again, we've done a bunch of these, so it should be getting easier. And you know the expectations, but again, I'm just going to give you a brief overview of each section. So again, purpose, it's 1 to 2 sentences. Again, talk about what you're trying to find. And in this case, talk about what you're trying to compare and see how it affects what variable, right? So it's a little bit different. You weren't trying to find an exact answer or stuff like that. You were trying to compare how different variables affect a variable, and see how that happens. Okay. So again, 1 to 2 sentences explaining that. Introduction theory, 1 to 2 pages, nothing new here. Include diagrams, stuff like that. So I've made a list for stuff you should be talking about. You should be talking about what is kinetic energy, what is potential energy, what is spring energy, how do they relate, what is total mechanical energy, what's the law of conservation of energy state, all right, what is work, how does that relate to the law of conservation of energy, stuff like that. So it should be easy to get 1 to 2 pages here comparing this. All right. Materials list, easy. Procedure. Again, just how you obtain the data. Okay. Step by step. Make sure it's very clear. Okay. Step by step. Make sure you're telling me what variables I need to change. Make sure you're telling me what variables I keep constant. Okay, so this one might be a little bit longer because you can't say repeat steps there because you're changing different things. Now, yeah, you can say it. So if I'm talking about changing the mass and I say, oh, change the mass, keep it, okay, then repeat steps this to this for 10 data points. But then when you change it to spring constant, you can't just say repeat the steps as that. You have to say, okay, I'm changing my spring constant, and I keep this, and this is the same. Okay. So again, your procedure here might be a little bit longer than normal. All right. Calculations. There are no calculations necessary. Oh, I skipped one. Data. Okay. So this is the big thing here. This is your big point, your data. So you are going to have 3 data charts. Okay. So you're going to have mass versus velocity. You're going to have spring constant versus velocity, and you're going to have spring displacement versus velocity. Those are the 3 things you're going to be comparing and how they change the velocity. Okay. So again, for each thing, and I showed you this, you should have a data table. It's the raw data table. It's very easy. Data should be very easy. Um, Now, when I talk about graphing, okay, we talked about, all right, what is your independent variable and what is your dependent variable? Well, what did we keep changing? Well, it's going to change for each 3 of the graph or each 3 of the data points, right? So for say you did mass first. So that's what you were changing. So that'd be your independent variable. What did that change? Well, it changed your velocity. So that's going to be your dependent variable. So right there, you should know that velocity is going to be on your y, because that's the dependent, and mass is going to be on your x. Okay, so that's comparison. The next comparison, okay, so you have a whole nother data table of data for what's it called? I guess it's spring constant versus velocity. So again, you kept changing the spring constant, okay? So that's going to be your independent variable, and your dependent variable on the y is going to be velocity. So you're going to make a graph of that. Then what you're going to do is the last one is spring displacement. So spring displacement, how far you compress the spring, is going to be your independent variable. And on the y-axis, that's going to be velocity because that's your dependent variable. I actually think I have, let me see here. I think I have a data example. Yeah, let me pull it up here so I can kind of show you what I'm talking about. Okay. All right. So notice here, here's my data that real quick, you should have 10 data sets. I don't because I was doing it really, really quickly, okay? But I'm just kind of showing you the graph here and what you need to do. So again, I label it like this is my velocity. I'm comparing it versus mass. So, as you can see, my mass is changing, okay? This is what I'm recording. I'm recording the time, and then I calculate the velocity, right? You don't need to make these columns. What you could just do is say up here, K equals 1,000 and X, the displacement, equals 1. And that way you would know just for reference, and you could actually delete those. So you're just looking at that. Same thing down here. I could say mass equals 55 and X equals 1. Just knowing that these are the ones I kept constant and they don't really affect the data, right? They're the constant values here. All right. So what you're going to do is you want to graph. Again, what we said is what we are changing is mass. So mass has to be on the x-axis and velocity has to be on the y-axis, okay? So let me show you how to do that in case you forgot. Now, your graphs are going to look a little bit better than mine just because you're going to have more data points. I only have, 5? So I have half the amount that you need. So what you're going to do to make the graph, you're going to highlight it, mass, velocity, and then you're going to do the same thing. You're going to go here, insert, and then you're going to go to scatter plot and hit this scatter plot. And there you go. There's your graph. Let me make it a little bit smaller here. Okay, and as you can see, my mass, because I look at here, my mass is on the x and my velocity is on the y, so I'm good to go. I don't need to change anything. I'm good. To add, so now one of these is going to be nonlinear. You can't really tell from my graphs because I don't have enough data, but one of them is going to be nonlinear. Okay, so just observe that and make sure you change the, so to add my trend line here, I said add trend line like I normally do. And then what I want to do is display equation on the chart. And then I'm good to go. So I just basically showed you which one's nonlinear. Hint, hint. So you're going to have to probably linearize this one. Okay. And I put the linearizing chart thing. So let me show you. You can't tell from looking at the graph just because I don't have enough data points, but I just gave you the real big hint. So you can use this to tell the relationship. What does it look like? There's another big hint. It kind of looks like this one. If you can see my mouse, hopefully you can see my mouse right there. All right, so that's a huge hint, okay? So going back to my data, now I do the same thing down here. I look at this, okay? So these are my data table. This is exactly what your data table should look like. This is exactly what your data table should look like, except have 10 points, okay? Now, this time I'm graphing the spring constant K compared to velocity. So I do the same thing. I highlight both of those. I hit insert. I hit charts. There's my thing. Bang. Okay, sweet. I hit add trend line. And I get this. And I display equation on the chart, and there I'm good to go. Okay, yeah. And then you're going to do the same thing for what's it called, spring displacement, right? Okay, and then once you get that, that's your 3 graphs. You have to linearize one of the graphs. this one if you didn't get the hint by now. Okay, so there's how you do the data. Let's go back to the now. Since there's no calculation, you need to analyze each section. So what I expect to see, so this is how I expect to see it. I expect to see the data chart. I expect to see the graph, okay? And then a paragraph analyzing the data there. Tell me what the independent, tell me what the dependent, tell me what you held constant. Tell me the relationship. This is the key. Tell me the relationship between the two variables, the independent and dependent variables. All right. If you had to linearize, tell me how you linearized and what you got from that. Then tell me the relationship. So it should be, so for each three, so it should be like this: mass versus velocity data table, mass versus velocity graph, linearized graph. I'm telling you the answers. Paragraph explaining. Next, spring constant versus velocity data, spring constant versus velocity graph, paragraph explaining and analyzing that data and graph. Last thing, spring displacement versus velocity data, spring displacement versus velocity graph, a paragraph explaining the data, independent, dependent, and relationship. So that is your whole data section. There is no calculations because you're just analyzing data. Okay, I've literally given you the answers. So please make sure you have all those sections. Rewatch this 10,000 times until you make sure you have all of it. All right. Conclusion, again, basic things, summarize what you found, and then give me a source of error or sources of error if we were to do this experiment in real life. Talk about work, talk about stuff like that. So talk about where could you lose energy? Where were there errors possibly? Okay, this should be easy to get a whole bunch here. All right. So again, this lab right should be easy. There's no calculation. You're just analyzing data. You're making graphs in Excel. I showed you how to do that. You can rewatch it. Again, easy stuff here. All right. Hopefully this laid it out pretty clear so everybody can get a good grade. All right. Thanks.